Okay, so I think we should get started. So it's really nice to see so many coming here for this session with the lightning talks. So my name is Håkan Silfvernagel. I work as a senior consultant at Miles, and I'm going to be talking about the history of AI and what can we learn from the past. But first, a couple of facts about me. So I have my background in software development in process automation and robotics. I worked on the .NET platform since its release in early 2000s. And I have 19 years experience in lots of different roles in this business. I'm also very interested in machine learning and artificial intelligence. So that's the reason why I'm giving this talk. So if we want to know the origins of AI, we have to go back, all the way back to the middle of 1950. So in the summer of 1956, there was a group of researchers who proposed a workshop. So many of these researchers were quite famous, and a lot of them won several prizes after this workshop. So for example, John McCarthy, he's the guy who actually invented the term artificial intelligence. He also invented a programming language called Lisp, which was specifically constructed for this purpose. Another guy was Marvin Minsky. He built the first neural net out of vacuum tubes, and he won the Turing Award in 1969. And the third person was Claude Shannon. He's mostly famous in the information theory sphere, but he worked on how you can construct an analog computers using just cog and wheels. So this was the proposal for the workshop. So basically they proposed that if they work during the summer, just 2 months with 10 persons, they will try to study every aspect of learning or any other feature of intelligence, so that they can describe it so that a machine can execute it. And they think that if they reserve the right persons and this time, they will be able to make significant advances just during this summer. So here we are about 70 years later, and we still, we have not delivered on these promises. But it can be interesting to see what were they focusing on in this workshop. So one of the things that we need to clear is how can we represent objects and knowledge? So this is John McCarthy sitting in front of his computer, programming Lisp, and he was concerned with what are objects and what are people, what are languages. Another field is planning in robotics. So here in the picture we can see the first self-driving robot from 1972 called Shaky. So in robotics it's important to be able to navigate, to do pathfinding, and to be able to decide what if you have multiple ways, which way should you be able to take. The third area was in the natural language processing. So we have to remember this was in the 50s during the Cold War, so there were not so many people in the US speaking Russian. So one of the first tasks for the NLP projects was to translate between English and Russian. So I'm going to say a couple of words more about that later on. And then the fourth area was the area of perception. So this is Marvin Minsky at MIT. He was concerned on how can a computer understand sight and sound and smell. So here he's trying to teach a robot to be able to understand the different sizes of some cubes and how they can fit together. But the ultimate goal of everything of this is to reach what we call generalized intelligence. So that comprises both emotional intelligence, creativity, moral reasoning, and intuition. So the idea was by combining these different building blocks, we would be able to reach this generalized intelligence, which is the goal. So that's quite a hefty goal in 1956. We have to remember that at that time, the computer standard was a mainframe and punch cards. So we can clearly say that these guys were visionary. So they had some successes initially, but then the AI winter happened. So the AI winter is a concept taken from the atomic and nuclear winter. So basically what happened was that they had some ideas and they were making some progress, but then due to the technological state of that time, they couldn't really deliver fully out on it. So therefore we should actually call it AI winters, because this happened, there were like a boom and bust cycles both during the 60s, 70s, and 80s. So we're going to have a quick look at some of these things. So the first AI winter was in the 1960s. As I said, translating between Russian and English was top priority. So what they did was they had a punch card with English letters and sentences, and they punched that into an IBM 701, and then they got the Russian translation back. So we can see an example of this. So this is a sentence from the Bible. It says, "The spirit is willing, but the flesh is weak." And then they put it inside the computer, and then it direct translated it back to English, and then we can see what the result is. So as we can see, if we just take it word by word, maybe the translation is okay, but the whole context and the capture of the meaning is totally lost. So this was the reason for the first AI winter. Federal Committee said that the progress of machine translation was so slow, so let us not spend any more research budget on this thing. This is not worthwhile. And we fast forward to the 1970s. Then there was a guy at MIT, Terry Winograd. He came up with a concept called Microworld, because as you could see, translation can be really wide. It's difficult to understand and capture the meanings. So what if we try to constrain this problem instead and construct like a microworld? So as you can see in the picture, what he was working on was with building blocks, and the computer should be able to decide which building blocks can fit and which building blocks belong together and so on. So he had some progress on that. But the problem here is also, as soon as you come outside of these constraints, the computer just will give you random information that you can't really make any use of. So the government in the UK said that AI has utterly failed to achieve any of its grandiose objectives. So that was the second AI winter. And this continued on in the 80s with more AI winters. But now the question is, how can AI be popular now these days? And the answer to that is deep learning. So previous to deep learning, when we try to instruct these machine learning algorithms, we had first to interview a human expert, and then we had to withdraw his information and basically type it into a computer so the computer could understand the same knowledge as the human person. But with deep learning, what we do instead is that we feed the data right into the deep learning structures, and these are modeled on the human brain. And then the algorithms help the system learn. So we don't need this human expert from the beginning. So one breakthrough in deep learning was in 2012 with Andrew Ng. He wanted to try to classify the information we had on YouTube. So he used 100 million videos, and he took screenshots, still screenshots 200 by 200 pixels, and he ran this for a week. And the question is, what did he find? He found cats. But he didn't just find cats, he found thousands of other objects. And the interesting thing here is that we didn't have to describe what a cat is, we didn't have to describe its separate features. Instead, we could just feed this network a bunch of data, and then the system itself will figure out this classification. So a little bit later on, we had a game called Alphago, and at that time the researchers said that a computer will not be able to beat a human in Alphago. It's at least 5 years away. But that happened just later on the same year. So Alphago won against the leading champion Lee Sedol with 4 victories out of 5. And this was trained by first, he was mimicking human play. But he had a database with 30 million records of historical moves. And then after that, the Alphago system trained by playing both against itself and against other using reinforcement learning. But then less than a year later, we had the Alphago Zero, which just in 40 days, it surpassed all the previous Alphago systems using reinforcement learning. And the difference here was the first Alphago system, it needed to have this database with the results from the human matches. But here with the Alphago Zero, it had zero knowledge about Go. It just had the data. The question is here, we have 2 different categories, either artificial general intelligence, which is that the machine should be able to perform any intellectual task that a human can do, or we have narrow intelligence, which is the machine is focused on a specific problem solving. So if we reach artificial general intelligence, some people think that this could be a threat, and some people think that this could be a hope. So I'm just going to conclude by just having some quotes from the people, and we can see what does history tells us. So Elon Musk, he said that artificial intelligence were summoning the demon. AI is our biggest existential threat. And we had Stephen Hawking. He said that the development of full AI could spell the end of the human race. So that's quite drastic. But what did people in the past say? So we had Marvin Minsky, who was one of the founders here from the original workshop. In the 1970s, he said that once the computers get the control, we will never get it back. We will survive at their sufferance, and if we're lucky, they might keep us as pets. But you know, that's in the 1970s, and it still hasn't happened. And then we had some other researchers that said that symbol systems modeling is the right answer. So we better alert the people in the world, because this is really dangerous. And this was also in the 70s. In the 80s, there was a researcher called Fagin Baum. He said that Japan will dominate the whole world because they are using rule-based systems. But as we know, that didn't really happen. So what does people say about the future? Well, maybe we should form a partnership so that we can have what is called collective intelligence. That's a combination of human and computer intelligence. So we let the computers do what they do best, and humans do what the computers can't do. So we also know that collections of people will perform much better than an individual. And the same thing will work here. So collections of people plus computers will be able to achieve more than a collection of humans or a collection of computers. So that's basically what I wanted to say. So thank you for your time.